Linear repeated factors. This is the second example where I'm going to show you how to decompose or how to resolve a fraction into its partial fractions, given that the denominator has a repeated factor. And having a close look at the denominator, you see that the repeated factor is x plus 1. So I have x plus 1 times x plus 1 times x plus 2 in the denominator. So when I resolve this fraction into its partial fractions, I'm going to resolve it into 3 fractions. And my first fraction, I'm going to write it as a all over x plus 1. My second fraction will be b over x plus 1 squared, because x plus 1 is the repeated factor. And my last fraction will be c over the last factor, which is x plus 2. And this will equal to 1 all over x plus 1, x plus 1 times x plus 2. You could even have just written it as x plus 1 squared over x plus 2. So having a look at this question, I need to find the values of a, b, and c. So I have 3 unknowns. So it's really a very complicated question. So to help me to find the answer, we're going to use the cover-up method to maybe find some of the unknowns, either A or B or C. The question is, which unknowns can I find using the cover-up method? So the cover-up method will help me to find the value of B, because when I have a repeated factor, I can only find the numerator of the fraction that has the repeated factor in the denominator. So I'm going to use it to find b. So I'm going to cover up x plus 1 times x plus 1. And you could use your finger to do so. And I know that if my denominator is x plus 1, I'm going to write it on the side here. If my denominator is x plus 1, then I solve for x equals to negative 1. So what I'm going to do is I'm going to substitute x equals to negative 1 into this right-hand side fraction, and that will give me the value of b. So b is going to be 1 over, it's going to be minus 1 plus 2, and that gives me 1 over 1. So the value of b is 1. I can use the cover-up method to find the value of c as well, because c has a linear factor, and I'm going to do so now. So I'm going to close the denominator factor x plus 2. So now we cover up x plus 2. So with your finger, you hide x plus 2. And once again, I know that if x plus 2 is my factor, then x equals to negative 2. And I substitute the value negative 2 into the right-hand side, and that will give me the value of c. Because when I use the cover-up method, the factor that I cover up gives me the value of the numerator above that factor. So c is going to be 1 over, and I substitute, I've got negative 2 plus 1 times negative 2 plus 1, which I write is negative 2 plus 1 squared, and that's going to give me a value of c. So c has a value of 1. Substituting these values, so I still need to find a. I have a over x plus 1. I found that b has a value of 1, so I replace it, so it's 1 over x plus 1 squared. C has a value of 1, so it's 1 over x plus 2. This equals to 1 over x plus 1 squared times x, which I'm going to write as x plus 1 times x plus 1 times x plus 2. So now I'm going to find the lowest common denominator. My lowest common denominator is going to be x plus 1 times x plus 1. I write it as x plus 1 squared times x plus 2. And I'm going to now simplify this. So that means I'm going to multiply each numerator by the missing factor of the denominator. So my denominator in my first fraction is x plus 1, so a must be multiplied by x plus 1 times x plus 2. My second fraction must be multiplied by x plus 2, and my third fraction must be multiplied by x plus 1 squared, and this will equal to 1. So I'm going to remove the brackets across. So I have a, and if I multiply using the method of FOIL or the distributive law, I will get x squared plus 3x plus 2 plus x plus 2 plus, I multiply x plus 1 squared, so it's x plus 1 times x plus 1. I will get x squared plus 2x plus 1, and this equals to 1. So I remove my brackets here, so I have ax squared plus 3ax. So we have 3ax plus 2a. Are there terms that I can add here? Yes, I have x squared. 2x added to x gives me 3x plus 3 equals to 1. So you do not need to continue simplifying here, because what you're going to do is you're going to look for terms that you can equate. So I'm going to equate all of the terms that contain an x squared, because I need to find a. That's the only thing that I need to find as efficiently as possible. So I have ax squared. Let's just highlight it. I have ax squared, I have x squared, and on the right hand side I have no x squared. So I'm going to write this as an equation. So ax squared plus 1x squared will equal to 0x squared, because I have no x squareds on the right hand side. If I remove the x squareds, I can see that a plus 1 equals to 0, so the value of a is negative 1. So now that I've found all of my values, I substitute them. So my fraction will be resolved into the 3 partial fractions, and a is negative 1, so it's going to be negative 1 over x. So it's negative 1 over x plus 1. The value of b, I found it to be 1 over x plus 1 squared. And I found c to be, the value of c, let's just erase that. The value of c is 1. And this is over x plus 2. And you can still insert brackets around each denominator if you want to, and this will give you the fraction 1 over x plus 1 squared times x plus 2. So just to recap, sometimes it's easier to start with the cover-up method and find 1 or 2 of your numerator unknowns, and then continue simplifying and finding the others.